Dear students, good afternoon, everyone. Today, today I have discussed advanced quantum mechanics. This is fourth class, online class. So this is topic is the variation method third unit. Unit unit 3. So unit 3 variation method. Variation method. So variation method is the what is the variation method? You find out this. The method is based on the basic principle of that a wave function, and other that the wave function is given the expansion value of that is always larger than the ground state energy. The ground state energy, it is maybe expressed for the arbitrary wave function, arbitrary wave function, arbitrary wave function. That is arbitrary wave function is wave function is equal to psi. That is psi. That is psi. So that is psi. That is the psi is equal to, we find out the ground state energy value. First, we calculate the ground state energy. Ground state energy is equal to E naught. So that is your wave function value and ground state energy value. We are using this formula. Ket bra psi of H ket bra psi less than or equal to E naught. Less than or equal to E naught. Here the equality sign holds good with the arbitrary or trail wave function. All trail wave function is proportional to is proportional to the exact ground state. Exact ground state. That is ground state. That is phi n phi n phi n is equal to eigenfunction and eigenvector, eigenfunction and eigenvector and eigenvalue. If three values are substituted that corresponding to the wave eigenvalues, correspond to the eigenvalues of the Hamiltonian H, of the Hamiltonian H, that is eigenvalue equation H phi n is equal to E n by n. That is equation. First one is equation 1. This is sorry, equation 1. This here is equation 2. So equation 2. That is n is equal to 0, 1, 2. Dash dash. So here E naught greater than En for n greater than 0. N greater than 0. The proof of variation principle, let us the simple expand the trail wave function psi in terms of template. The orthonormal set This is the orthonormal set. Orthonormal set bracket ket pi n bracket and the and expand the trial function in the term of set complete the system. It is describe the Hamiltonian. This is the describe the Hamiltonian 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 is equal to H. Hamiltonian H. So that is formula you calculate this Hamiltonian H. The next point is the trial wave function. The trial wave function. The trial the trial wave function. Wave function. That is the wave function. Wave function phi n. Phi n. It is the can expand in the term of complete set of the uh, eigenfunction of pi n. Let us here here uh, ket 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 psi is equal to summation n cn bra phi n sigma. So here Cn is the expansion coefficient. Cn is expansion 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 coefficient 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 coefficient. The trial function psi is the trial function the trial function the trial function is equal to psi. So here the wave function and trial function is the normalized both value are using here. That is ket psi by psi is equal to summation 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 k cn pi n cn pi n cn pi n by summation n cn pi n bracket is equal to summation 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 k summation n c c star c star k ck cn into pi k comma pi k comma pi n. Okay. So this is the simplify here. The simplify here. Uh, ket psi comma psi is equal to ket cn summation k n Kn and Cn delta Km. Okay. So here this is that K is equal to is a K is equal to N is a that put this formula psi of psi is equal to summation n Cn 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 modulus of square is equal to 1 is equal to 1. So is equal to 1. So this is equation. So on the equation is the equation 3. Equation 3 here, equation 4 is the equation 4. So equation 4 continuously here, equation 4, the expectation value of H, the expectation value of this, the expectation, the expectation, expectation, the value of expectation of value uh, H obtained obtained the obtained by with obtained by with the trial function, trial wave function, trial wave function psi is equal to psi is the psi is this is uh, E is equal to sorry that is here we will take this side ket E is equal to psi psi H by psi is equal to summation n Cn square En by summation n Cn square is equal to summation n Cn whole square En. This is the equation. So this equation you are multiply the ground state energy E naught. Multiply the ground state energy E naught from the both side. This equation, both side the multiply the both side is the equation. We get that. We get that. This is equation 5. You say this is a 5. So multiply this, uh, multiply, multiply this, multiply this. Which one the equation? Multiply this E naught from from uh, from the both side, both side, both side. So that is we get, comma, we get, what is this? Here summation E minus E naught is equal to summation n Cn of square Cn minus E naught. E naught. So E naught. So this is equation. The equation. The since here Cn is this is the Cn value. Here Cn is greater than equal to greater than greater than equal to E naught and modulus of Cn square is always positive of 0. Positive of positive or 0. So here ket E ket E is either ket is either it is either greater than greater than greater than or equal to what is that? Equal to E naught. That is that is that is that is E minus E naught greater than or equal to 0. Here E is equal to psi So so here here the E naught is equal to 0. E naught is equal to 0. So this sum. Sorry, disturb. This is psi h dot psi uh, psi h dot psi Kedbra greater than equal to E naught. Okay. So so this is equation. This is equation uh, 6. Equation 6. This is equation 7. Hence we do not know the exact the ground state energy E naught. We want to find the and approximation from the value by the variation principle, and our approximation is using any trial wave function. Any trial wave function get psi will always be greater than the exact value of E naught. Exact value of the E naught. Whence the lower the expectation value of ket h, that is closer to the exact value, the better the trial wave function. In practice, the trial wave function psi is selected in the term of one or more variables, the parameters and the value of h evaluated. The value of h, the when minimized in the respected to the each of the parameters, that is one get of the close the estimate possible with the select trail wave function. A good trail wave function is slight modifying of noun wave function whose the h is only slight different from the h of the system under consideration. Under consideration. That is the draws a wave function that that is draws wave function that is the draws wave function psi of alpha 1 comma alpha 2 comma alpha 3 comma dash dash. Okay. So is the number of variables parameters with the number of variables 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 parameter variables parameters alpha 1 comma alpha 2 comma alpha 3 dash dash. the wave function, the wave function, the wave function, the wave function is not normalized. The it not is not normalize 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 the what is psi of psi is equal to 1. Psi of psi is equal to 1. The find the expectation value of Hamiltonian. The find the find the expectation expectation value of the Hamiltonian 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 state psi of h psi is equal to h into alpha 1 comma alpha 2 comma alpha 3 dash dash bracket is equal to e e this is e amma not summation. Uh, uh, so that is e is equal to e into alpha 1 comma alpha 2 comma alpha 3 dash dash. So here the minimize the expectation value, the minimize the expectation expectation value is equal to h alpha 1 comma alpha 2 comma alpha 3 comma dash 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 that. So here finally uh dou h into alpha 1 comma alpha 2 comma alpha 3 dash dash by dou alpha 1 is equal to dou h alpha 1 comma alpha comma alpha 3 dash dash dou alpha 2 is equal to 0. This is the solve the simultaneous equation and obtain the specific value of lambda 1. The substance of the value of h into alpha 1 comma alpha 2 comma alpha 3 dash dash. So this is the obtain the minimized possible value of energy with the grasped wave function with the number of variation parameters. Next one is the specific value of the alpha 1 specific value of specific specific value of alpha 1 in psi of alpha 1 comma alpha 2 comma alpha 3 like that. రాజీ ఆ క్లాస్ లో ఉంచు. So, alpha 1. So this is that clearly the success of the non-participative method will be depending on the main of form of the trial wave function we choose the start with. The variation method can also be used to find the approximate value of the first few excited state. First few excited state. However, the variational procedure becomes increasingly the complicated as deals with the higher excited state. As a result, the method of mainly used to determine the ground state energy. Ground state energy. So this is the variation method. This is the variation method. Okay. So next second one, the second one, application of the second one, the application of so the application of here. Anyone please? Hello? Hello?
Yes, sir.
Hello? Voice is clear, Andy?
Yes, sir.
Okay, understood?
Okay, sir.
Okay, thank you. So next one is this is application to ground state of helium atom. Application to ground state of helium atom. This is very, very important question. Is a 10 marks question. 10 marks question. So here, this is in this section is the exam the ground state energy of the helium atom by means of the variation method. The helium atom consists of nucleus of charge. That is, this is, you will take the diagram. This is the diagram. This is you have two electrons. These are two electrons. Here is distance the R1. This is R2, R1 and R2. This is the JD. This is the diagram. Here is R1, R2. Okay. So you have to this diagram. The application of helium atom is you have two electrons. That helium atom. Here two electrons that is the charges. You have two charges. The surrounding by the two electrons of charge minus E. If we consider the nucleus to rest, the Hamiltonian will be. This is equation. Hamiltonian Hamiltonian. H is equal to h cot square by 2m into delta 1 square plus delta 2 square in minus z is square into 1 by r1 plus 1 by r2 plus e square by r1 r2. This is third unit, Amma. This is third unit. Page number 56. Page number 56. Open your textbook also. But the equation. Now to the equation. Here, this also here minus is take. This one. If minus is common here. Minus is common. You will take. Next, h is equal to bracket minus h cot square by 2m. Multiply this sum. Here, this multiply here. Okay. Here to here, multiply this. Total values of multiply that. Okay. Minus h cot square by 2m delta square, delta 1 square minus z square by r1. So place minus h cot square by 2m delta 2 square minus z square by r2. Place, you write this equation, this. Okay. So place e square by r1 2. E square by r1 2. So here where here delta 1 and delta 2 are Laplacian operator. Laplacian operator. Okay. The first and second electrons. The first and second electrons and second electrons at the distance r1 and r2 from the nucleus of r12 is equal to modulus of r1 minus r2. The modulus is distance between the two electrons. That is e square by r1 to r12. This is the represent the electrons. This is the represent the electrostatics repulsion between two electrons. So, repulsion between the two electrons mean, you see this here, this is one equation and this is also one equation. You have to two Hamiltonian equation there. This is the H1 value. You total you will take this is the H1 value. Here another one is you will take the H2 value. Okay. Only you will take this is the H dash value. You have to three equations. Here you will take this only H1. Here H2. This is H dash. You will take the three equations here. Okay. So so this here H1 is equal to H1 is equal to H1 is equal to minus H star square by 2m delta 1 square minus Z G square by R1. This is equation. This is equation how much? The equation 3.8. The number of equations you have to equation sum. Here, next one, comma H2. H2 is equal to minus H star square by 2m delta 2 square minus ZE whole square by R2. R2. Here, comma H dash is equal to you write this equation, this one here. You write this is the H1 value, this is H2 value, this is H dash value. What is that equation here? E square by R12. R12, that value is equal to, what is that formula? E square by modulus of R1 R2 value, write that value modulus of R1 minus R2. Okay. So here, therefore, H is equal to, actually the formula H is equal to H1 plus H2 plus H dash. H1 plus H2 plus H dash. So here, the total value, you write this value is H0, Hamiltonian function. H0, you write the H0 value. So here, what is the formula there? Finally, H is equal to H is equal to H naught plus H dash. Okay, you write that is the equation 11 or that one. This is equation 3.8. This is the equation 3.8. This equation 3.9. This is equation 3.10. 3.10. Here equation 11. Sorry, this equation number. 11. Equation 3.11. 3.11. So this is the applied the Schrodinger equation. The Schrodinger equation corresponding to the exactly solve value, that is exactly solve the value here, bracket of minus H star square by 2m delta 1 square minus Z2 square by R1 is equal to E1 naught psi 1 naught 0. This is the equation 3.12. 3.12. So that is, you write that this is the equation. You write the equation psi 1 naught is equal to under root of z cube by 5 alpha naught cube into e power minus zr1 by alpha naught. This equation, uh, this equation, this equation we observed, observed, we observed equation 1.36. 1.36. Before class, I am telling this equation is simplification part. Amma. Okay. Equation 1.36 and 1.37. Okay. 1.36 and 1.3. And okay. So that is the simplify this. Uh, simplify this here. E naught dash is equal to z square me z square if me power of 4 by 2 h dot square is equal to minus z square e h dot e h power of 0. This is the equation is the equation how much? You will take this equation 3.13. Equation is 3.14. Equation 3.14. So here next one, the minus h dot square by 2m delta square 2 minus j square by r2 r2 psi 2 naught is equal to e2 naught psi 2 naught. This is equation 3.15. Next one, this is also psi 2 naught is equal to under root of z3 by 5 alpha naught cube into e power of minus ze square by ze alpha naught naught ze alpha naught. Okay. So z r2 amma. This is the e power of not this e power of z r2 by alpha naught. Okay, e exponential that. So this is the equation 3.16. Next one is e2 naught is equal to z square me naught me power of 4 e power of 4 by 2 h dot square is equal to minus z square EH naught. This is equation 3.7. 3.7. So here alpha naught is the radius of the orbit orbit and is driven by alpha naught is equal to minus h star square by mg naught square. This is equation 3.18. Okay. So if the electrostatics interaction between between two electrons is ignored, the ground state eigenfunction of the helium atom would be the product of to normalize the hydro, hydrogenic ground state. Hydrogenic ground state. The ground state, the wave function. Let us choose a trial wave function. Let us choose the choose the let us choose the trial wave function. Choose the trial wave function. Psi naught of R1 comma R2 then psi naught psi naught of R1 comma R2 is equal to psi 1 naught R1 into psi 2 naught R2. This is equation 3.19. This is psi naught into R1 comma R2 is equal to Z3 by pi alpha naught 3 into e power of minus z into R1 plus R2 by alpha naught. This is equation 3.20. Okay. So this is the corresponding to the eigenvalue is the corresponding eigenvalue is E naught is equal to H naught is equal to H1 plus H2 is equal to E1 naught plus E2 naught is equal to minus 2Z square H naught. This is 3.21. You see this equation. First, listen this. Hamiltonian is the equation is the form of this sum. So here you have three equations are there. This is alpha H1 and H2 and H dash value. These three values of depending on the Laplacian operator, that is the delta 1 and delta 2 value. This is the distance of electrons. That is the first and second electrons of distance is R1 and R2 from the nucleus. That is the R12 is equal to modulus of R1 minus R2 is distance of between the two electrons. That two electrons is equal to E square by R1 R2. Sorry, R1 2. So here you write this. This is the H1 value, H2 and E dash value. Here you also write the same value there. Yeah, H1 value and H2 value and H dash value. After that, you find out the Hamiltonian equation. So that is H is equal to H1 plus H2 plus H dash. So H1 plus H2 plus H dash mean this is the equation. Which one is the equation there? Equation 3.8, 3.9 and 3.10. That value are substitute this, you write this equation. So after that is the form of the equation, Hamiltonian function and Hamiltonian equation that is equal to Hamiltonian. H is equal to H naught plus H dash value. This is the equation 3.11. So finally, this is equation minus H naught square by 2m delta 1 square minus ZE square by R1 is equal to summation 1 naught plus psi 1 naught. Equation 3. This equation depends in the application of your observe the Hamiltonian equation. Yesterday class I am telling this offline class. Unit 1. Unit 1 this question is already given. I am telling this on answer. Yeah, all of you see that question number which one? Equation 1.36. This question already telling that before class. Observe all of you see that equation 1.36 and 1.37. 1.36 and 1.37. This sum 1.37 equation convention. Equation, yeah. Equation 1.36 and equation 1.37. That is our observed. All of you see that. So after your eigen energy, eigen function here E naught is equal to Gz square value. We have to see this. This is only E naught 1. Okay. Another one is E naught 1 and this which one is this sum. Psi 1 naught this equation, psi 2 naught this equation. Okay. Psi 1 once again. Here psi 1 naught this equation and psi 2 naught this equation. You have to this E1. This is not E naught. That is not E naught. So that is E1 naught. E1 naught. So E1 naught is equal to this. E2 naught is equal to this. Understood? E1 naught, this equation. E2 naught, this equation. Here, psi 1 naught, psi 2 naught, E1 naught, and E2 naught. If four equations you are substitute this equation here. Understood? So the total equation is a simplify. After that, it came up the corresponding the eigenvalues. E naught is equal to H naught is equal to H1 plus H2. That is E1 naught is E1 naught plus E1 naught plus E2 naught is equal to minus 2Z square 2Z square EH naught. That is 3.21 equation. Okay. They are simplify the finally E1 naught plus E2 naught plus two equations you are adding. After some values is a cancel. Remaining values is calculate that finally you will came is minus 2Z square EH naught value. Understood? So that. So finally, but the trouble comes from the electron repulsion. Each electron represents the Straining of the negative charge of the partially sealed in the nucleus, so that the other electron actually see the effective of nuclear charge. Effective is the nuclear charge Z dash G. Okay, effective is the nuclear charge is the Z dash at say this. You say. Okay. So the somewhat less than of the less than some less than ZG from ZE. Okay. This suggested is that the use the trial function of the form trial function of the form of the form trial function of the form sin naught of R1 comma R1 comma R2 is equal to R1 comma R2 is equal to Z cube dash by 5 lambda naught cube into e power minus z dash of R1 plus R2 alpha naught. Okay. This is equation 3.22. Here will be trained the z dash is variable parameter. Here uh, z dash is z dash is variable parameters. Button parameter. That is simplify the equation. This is a 10 marks was a very lengthy experiment, question. So it is the convenient of to write the equation. This is the convenient. The convenient to rewrite the total Hamiltonian. The total Hamiltonian. The total Hamiltonian. Total Hamiltonian of helium, light atom as light atom as H is equal to minus H dot square by 2m delta 1 square minus Z dash E square by R1 plus minus H dot square by 2m delta 2 square minus Z dash E square by R2 plus Z dash by Z into E square into minus R1 into E square into 1 by R1 plus 1 by R2, 1 by R1 plus 1 by R2 plus E square by R12 dash the 3.23 equation. 2.23 equation. 2.3 equation. Okay. So this is the 3.23 equation number. Okay. So this is the expansion, the value, E of the Hamiltonian, H with the trial wave function, trial wave function, trial wave function, trial wave function. What is the trial wave function? Sin naught of sin naught of sin naught of sin naught of R1 comma R2. R1 comma R2. That is E is equal to sin naught 0 R1 comma R2 modulus of H dash naught H naught R1 comma R2. You write this equation. This is the equation. This value are substituted here above equation 3.23. 2.23. The total value are substituted that. So that is E is equal to H is equal to sin naught minus H dot square by 2m delta 1 square minus Z dash E square by R1 sin naught 0 plus sin naught minus H dot square by 2m delta square 2 minus Z dash E square by R2 Z R square by 2 modulus of psi naught.